Good morning to all of you. Today, our subject is engineering mechanics. Clear? Now, we'll start a new chapter, virtual work. Virtual work. The chapter name is virtual work. The subject is engineering mechanics. Engineering mechanics. For first and second semester, BTech students, the chapter is for first and second sem BTech students. Clear? Now, first I will clear what is work. What is work? Suppose this is a body resting at point A. The body is resting at point A, and after giving force F, the body moves to B through displacement S. Clear? Initially, the body at A, so after giving a force F, the body displaces from A to B through distance S or displacement S. So what is work done? Force on displacement. This is normal action Rn. Rn. Normal action Rn. Clear? We know first what is work. First, I will give you clear idea what is work. Whenever a force is applied on a body, then the work is said to be done. The work is said to be done. Clear? If a force F act on the body is acting on the body, and the body displaces or moves some displacement S, some distance or displacement S from A to B. Clear? A to B. This is weight down. Clear? Whenever a force applied on a body, then the work is said to be done. Clear? If a force F is acting on the body, as a result of this force, the body displaces from A to B through distance S. So what is done? Then what done is equal to F into S. Clear? What is unit? Newton meter. What is the Newton meter? Joule. So unit of what done is joule or kilojoule. If any inclined force acting on the body, suppose This force is along the displacement of the body, along the parallel to the motion of the body. If an inclined force acting in the body, suppose this body weight W, a force acting on the body. So as a result of this force, suppose this angle theta, body move from A to B through displacement S. Clear? Suppose this force F makes angle theta with horizontal. So what is what done? This is normal action Rn. Suppose this is force angle makes theta with y axis, x axis. So what is this component? This is F cos theta. What is this? F sin theta. Clear? So F sin theta move the body from A to B. So what is what done? F cos theta. F cos theta move the body from A to B. So what is what done? F cos theta into S. Clear? The force, the component of the force along the motion of the body into distance traveled by the body. Clear? If the force F makes an angle theta with x-axis, clear? Then what done is equal to F cos theta into S. Force, the component of the force along the motion of the body into displacement. So what is what done is equal to Fs cos theta. Right? This is what done. If theta lies between 0 to 90 degree. So special cases. What is what done is equal to Fs cos theta. Case 1. If theta lies between 0 to 90 degree, 0 to 90 degree. What is cos theta? Positive. Clear? Then what done is positive. Then what done is positive. Right? If theta 90 degree, case 2. If theta is equal to 90, what is cos 90? 0. So what is what done is equal to 0. Clear? If theta lies between if case 3, theta lies between 90 to 180 degree. What is cos theta is equal to? Negative. Clear? Then what done is negative. Then what done is negative. So this is about work. But what is virtual work? Clear? Now I will give the concept of virtual work. Virtual work. What is virtual work? The work done is the product of force and displacement in the direction of the motion of the body. But if the body is in equilibrium under a system of forces, then what done is zero. Clear? If the body is subject to a number of forces, if a body is equilibrium under a system of forces, then what done is zero. If in this equilibrium condition, the body be imagine some imaginary displacement, then some imaginary work will be done. This imaginary work is called virtual work. Clear? Concept of virtual work. We know the work done is the product of the work done is the product of force and displacement. Force and a displacement through which the body moves. The body moves. Clear? If the body be equilibrium under a system of forces, then what done is zero. Clear? If if the body is in equilibrium under the action of system of forces under a system of forces, then the work done is zero. Work done is zero. Clear? If the body moves from displacement, work will be done. If the body is in equilibrium, there is no displacement. The body will not move in any direction. So if displacement zero, work done is zero. Clear? If we assume that if we assume that the body in equilibrium, the body in equilibrium, we imagine we undergoes some imaginary displacement, some imaginary displacement known as virtual displacement. Virtual displacement, then virtual displacement, then some imaginary work will be done. Then some imaginary work will be done. Imaginary work will be done. Right? This imaginary work is called, this imaginary work is called virtual work. Virtual work. Clear? When the body is in equilibrium, displacement 0. The body will not move in any direction. So its work done is 0. If in this equilibrium condition, the body will imagine some displacement, body will assume some imaginary displacement, then some imaginary work will be done. This only in equilibrium condition of the body. This imaginary work is called a virtual work. Clear? So where this concept is used? This concept is used for finding unknown forces in structures and machines. This concept is used in finding the unknown forces in structures. Clear? Next, principle of virtual work. Principle of virtual work. Clear? What is principle of virtual work? Same theory, when body moves some displacement, by the action of a force, work is said to be done. If the body is in equilibrium condition, no work will be done. Clear? In these equilibrium conditions, if the body is be imagined to undergo some imaginary displacement, so imaginary work will be done. In this case, the average sum of the virtual work done by all the forces is 0. That is, sigma VW is equal to 0. Clear? If the body in equilibrium under action of number of forces, then imagine some displacement for each force and find out the work done, that force into imagined displacement. Then make all summation of all the forces 0. That is sigma VW 0. This is principle of a virtual work. Clear? Now write this theory. Principle of virtual work. Right? This is principle of virtual work. It states that if a system of forces acting on a body or system of bodies be in equilibrium, Means his body will not move in any direction. And if the system be imagined to undergo a small displacement consistent with geometrical conditions, clear? Very small displacement. That is imagined displacement. That is virtual displacement. Then, so virtual work will be done. Clear? Then the ideal sum of the virtual work done by all the forces of the system is zero. That is sigma v double is 0. Clear? I will first find out the virtual displacement for all forces acting on the body. Now find out the work done by force. Make summation of each all forces equal to 0. This is sigma v double 0. This is principle of virtual work. Right? Now I will make you sign conversion. Which force positive, which force negative. Sign convention. Number one, force towards right positive, towards left negative. Force towards right positive, whereas towards left negative. Towards left negative. Clear? Right side force positive, left side negative. Similarly, upward force positive, downward force negative. Number two, upward force positive, whereas downward force is negative. Clear? I have already given this idea in the resolution of forces. Right side force positive, left side force negative. Upward force positive, downward force negative. Similarly, clockwise direction of force positive, anti-clockwise direction of force negative. Clear? Number three, force acting in clockwise direction. Clockwise direction is positive, and force acting in anti-clockwise direction in anti-clockwise is negative. Clear? Next, tensile force positive, compressive force negative. Clear? Number four, tensile force positive, whereas compressive force negative. Clear? This is some convention for finding the virtual work for different forces. Now I will do some examples relating to virtual work. Now, one theory, application of virtual to simple supported beam. Application of virtual work to simply supported beam. Supported beam. Clear? Suppose or carrying point load. Carrying point load. Clear? This is simple supported beam. B may be this carries point load double. Clear? This carries point load W. Suppose this length is A, this length is B, right? And this is L, total length L. The question is find erection RA and find erection RB. The beam is in equilibrium condition. We have already calculated this RA RB by equating sigma y and sigma m. Now I will apply here the principle of virtual work. Clear? Let RA is equal to reaction at A. What is RB is equal to? Reaction at A is B. Right? Now I will give virtual displacement either at A or at B. Suppose I give at B. At B, suppose B moves to B dash. Clear? This is beam. This is beam AB. AB moves to AB dash. At B, suppose virtual displacement Y. Clear? Now, suppose this X, W, this is C, C dash. So W move to C dash. So distance X for A, distance 0. Clear? Again, I try to understand you. At B, give a virtual displacement Y to B dash. Similarly, the corresponding virtual displacement C is X up to C dash. But at A, the virtual displacement is 0. Clear? First find X in terms of Y. Imagine or give a virtual displacement, a virtual displacement y at B. Clear? The corresponding virtual displacement B to B dash. The corresponding virtual displacement virtual displacement at C is x. Clear? By at C x. But at the virtual distance 0. Virtual displacement is 0. Clear? Now comparing this triangle, ACC dash, ABB dash. Comparing triangle ACC dash and AB dash. Clear? ACC dash, ABB dash. Now this way this is equal to y by L. Clear? So x by A is equal to y by L. So what is x is equal to? This implies x is equal to y A by L. Now, according to principle of virtual work, sigma v dot is equal to 0. Clear? So minus w into x plus rb 0 is equal to 0. Now rb into y upward force positive minus w into x downward force negative plus r into 0 0. Clear? This is answer. I'll put the value of x and y and find rb, then find ra. Now this is 0. Clear? So rb into y is equal to w into x. So rb into y is equal to what is x? Y by L. Y cancels. What is rb is equal to w by L. This is answer of rb. Now I'll find out ra. Now what is ra plus rb is equal to w. Clear? What is ra is equal to w minus rb. So w minus w L. So w into L minus a by L. What is L minus a? B. W b by L. R is Clear? This is array, this is RB. Now I will do some problem. What is the problem number? 76 perhaps. This is question number 75. 75. The question is, a B may be loaded and supported as on figure. Using principle of virtual work, find the reaction at A, reaction at B. Right? The question is, a B may be is loaded and supported as on figure. As on figure. Using the principle of virtual work, find the reaction at A and B. This is question. Clear? Now, I'll do solution. Very simple question. Short question. It may be 6 mark or 4 mark. This reaction RA, this reaction RB. Right? Let B, the beam be given a small displacement up to B dash. Clear? Y. So displacement Y. This is B dash. So C moved to C dash, RB moved through to B dash, and W come to C dash. Clear? But A distance is 0. Right? Let RA is equal to reaction at A what is RB is equal to reaction at A B. Right? Give a virtual displacement, y at B to B dash Let's see this is x, this is y. Clear? Let's see the corresponding displacement x. Let's see the corresponding virtual displacement. The corresponding virtual displacement is x. Clear? Is x. From figure, comparing this triangle with this triangle. Clear? Comparing triangle ACC dash and triangle ABB dash. Clear? So x by 2 is equal to y by L, y by 5. So what is x is equal to 2 by 5y. So this is 0.4y. This is 0.4y. Now, according to principle of virtual work, sigma v double is equal to 0. Clear? This implies rb into y and double into x plus r into 0, 0. This is 0. Clear? So rb into y is equal to double into x. So rb into y is equal to double into or double O, 2 kilonewton. 2 into what is x? 0.4y. Clear? What is rb is equal to 0.8 kilonewton. Now what is ra plus rb is equal to 2. Upper force is equal to downward force. This is summation y is equal to 0. What is ra is equal to 2 minus rb, 2 minus 0.8. What is ra is equal to 1.2 kilonewton. Right? This is problem number 75. Next, problem number 76. The question number 76. The question is two beams A and BD. A and BD are supported on rollers at B and C. At B is a roller, C is a roller. Determine the reaction at B and C using the principle of virtual work. Clear? I'll find what is the reaction at B, what is the reaction at C. First take beam A, then take beam BD. Let RB is equal to reaction at B. What is RC is equal to reaction at C. Clear? Beam A, consider beam A. Clear? So this is beam A. This is a C E. This is 500 Newton. This is RC. RA. Clear? For this length. 3, 2.5, 5.5. This is 5.5 meter. This is total is 6 meter. So this is 0.5 meter. Clear? Now give a displacement y at t at B, not B at C. Give displacement y at C. That means B move, C move to C dash, E move to E dash. Clear? This is 500 Newton. RC go to C dash, but RB distance, RA distance 0. Again, I will make you clear. Give a virtual displacement y at C. The corresponding virtual displacement E is equal to x. Clear? At a 0. Now find x in terms of y. In the triangle ACC dash, AE dash. Comparing triangle ACC dash and AE dash. Clear? So y by 5.5 is equal to x by 6. Clear? What is x is equal to? 6 by 5.5 y is equal to x is equal to, or 1.09 y. This may be 1.09 y. Now apply principle of virtual arc. According to principle of virtual arc, sigma v double is equal to 0. Clear? 0. So for t 500 into x, negative sign, let C plus RC into y plus RA into 0. So what is RC into y is equal to 500 into x. What is RC is equal to 500 into x by y. So 500 into x by, what is x? 1.09 y by y. Clear? Find the answer RA, RC. What is RC is equal to 1.09 into 500 to 545 Newton. Next, beam BD. Go to beam BD. Beam BD. So this is beam BD, right? A B is a roller support, a C is a roller support, a P is a load, a D is support. Clear? This load is 750 Newton. This is RC. What is RC? 45 Newton. This is RB. This is RD. Clear? So the distance 3 meter. So C to F, BD, CF. So CF 3 meter and BC 2.5 meter. Clear? Now give virtual displacement at a B. Clear? At B, suppose this is distance U. This is B. This is W. Clear? So B move to B dash, C move to C dash, F move to F dash, at D 0. Clear? So this is RB. So RB move to RB dash. RC go from C to C dash. 750 go from F to F dash. Clear? First find out what is V and W in terms of U. Clear? Consider beam BD. Consider beam BD. Right? So virtual displacement at BU, C is V, F is W. First find out the two values in terms of U. From figure, U by this length. What is this length? 6 plus 2.5, 8.5 is equal to V by this by this. V by this length 6, W by this length 3. Clear? What is V is equal to? What is V is equal to? 6 by 8.5 U. What W is equal to? 3 by 8.5 U. Okay. Now apply principle of Vertual work. According to principle of Vertual work, sigma B dot is equal to 0. Clear? Start from here. RB throw U cross opposite upward. So RB into U minus RC into B minus 750 into W plus RB into 0, 0. Clear? Now RB into U minus what is RC? 545 into B. What is B? 6 by 8.5 U minus 750 into W. 3 by 8.5 U is equal to 0. Clear? This is 0. Now you cancels out. What is RB is equal to 545 into 6 by 8.5 plus 750 3 by 8.5. Clear? So use calculator and find the answer. The answer may be 648 Newton. 648 Newton is answer. Clear? This is our chapter name virtual work. Next class, I will do some problems relating to this chapter and then I will start dynamics. Clear? Thank you.